Hello dear children, we are here to do Acknowledge series by Amit Publishing House. I am Vandana and today we are going to do part 7 of your book. This is the cover page of your book. Let's click a trendy way to learn computers. So today we are going to do the first chapter of this book and the name of the chapter is Number System. We are aware with the numbers that we have learned from the early childhood of us. The numbers start from 0 and they are infinite. Let's learn about the number system in computer. From an early age, we are introduced to the concept of numbering and counting. Toddlers learn at an early age that they can carry 2 cookies, one in each hand. So from the very starting, when a child starts knowing things, जब बच्चे को पता चलने लगता है कि वो कुछ सीखने लगता है, we give them 2 cookies in both hand. When we give them some cookies, what they do? They take one in each hand. They know that they have to take 2. Kindergartens start counting by 2s and 5s. Invariably, we use the decimal number system. Our number system is based on 10, most likely because we have 10 fingers. So, whatever number system we learn, it is based on 10. Why? Because we have 10 fingers in our hand. Let us learn more about the number system. In this chapter, we are going to learn about number system, decimal to binary conversion, binary to decimal conversion and operation of binary numbers. So, as we know that our computer does not knows our human language. It knows something that is called binary language. A computer takes data from a user and produces result as information. So, we are the users here and whatever data that we give to the computer, that is used to give us the result as information. Although the words data are although the words data and information are often used interchangeably, means data and information इन दोनों words को हम एक के बाद एक continuously change करके use करते हैं. But there is an important distinction between the two words. What is it? In the strict sense, data consists of raw numbers that computer organize to produce information. So, what is data? It is the raw numbers that computer organizes and then just gives us the result. What is number system? Let's learn. A number system is a collection of numbers used to describe various quantities. So, what is number system? It is a collection of numbers which is used to describe various quantities. In this we talk about the quantities. There are many number systems in existence. Consider a clock. Clocks have 24 hours. Each hour is composed of 60 minutes. Each minute is in turn composed of 60 seconds. Then when you learn to count, you use the numbers like 1, 2, 3, etc. So here it is telling that when we see a clock, we can see the clock has 1 to 12 and it shows us 24-hour time. And in 1 hour or in 1 minute, we can see we use this number 60. 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So, we work on the number system here. We know the numbers from 1, 2, 3 and so on. Similarly, computer also have two number system, their own number system known as the binary number system. So, as I told you, the numbers that we use, computer does not uses that number. It has its own number system and that is called the binary number system. The digital computer represents all kind of data and information like audio, graphic, video, text and number in binary form. The total number of digits used in the number system is called base or radix. So, how the total number of digits used in the number system is called base or radix. Therefore, when someone says that they are working with number system of radix 2, it means base is also 2. So both are the same thing, radix and base are the same thing. That is binary number system. So the binary number system consists of two things, and that is two numbers, that is there are two numbers in it. We will learn about that. The base is written after the number as subscript. The numerical digits when we use today is 1, 2, 3, 4 are based on the Hindu Arabic numerals. So these numbers that we learn every day are based on the Hindu Arabic numerals. Different names for the numbers 0 include not, naut, nil, zilk and zip. So all these are the pronunciation of 0. So the meaning of all these words here is 0. इन सारे words जो यहाँ लिखे हैं इनके meaning क्या है? 0. The base is written after the number as subscript such as 512, and we can see it is given the number 10 is written outside the box. In this example, the number 10 is written as the subscript of to express the number in decimal number system. We say 512 as base 10 with base 10. So here 512 is there with base 10. So this is the way we write in our number system. There are four types of number system which are as follows: decimal, binary, octal and hexadecimal. These are the four number systems. We are going to read about them. First comes the decimal number system. So we all have used decimal numbers. We all know what are decimal numbers. So in computers language what they are, the decimal number system is a standard number system for denoting numbers. It consists of 10 digits from 0 to 9. So in the decimal number system there are 10 digits from 0 to 9. Only these digits can be used to represent numeric value in decimal system. So in computers we can use only numbers from 0 to 9 in decimal number system. Hence the base of decimal number system is 10. Here the base is 10. So this is a decimal number system. The decimal number system is most widely used number system. The value represented by individual digit depends on the weight and position of the digit. So we are going to learn about the weight and the position of the digit in the chapter. How this weight and position affects the number system. The position of first digit towards left of the decimal number point is 0, and the position of the second digit towards left of the decimal point is 1. Similarly, the first digit to the right is -1 and the second digit to the right is -2. So here I am going to give you an example. I have written here number. So here we have written 321.042. So this is written in decimal form. So here it is saying the number to the left. So first number to the left is 0 and the second number is 1 and the third number is 2. And again the first number to the right is termed as -1, second number -2 and third number -3. So in this way we form the decimal number system. We give the position to the numbers in the decimal number system. The value of the number is determined by multiplying the digits with the weight of their position and adding the results. This method is known as expansion method. So what method I showed you in the previous page, that is known as the expansion method. The rightmost digit of the number has the lowest value. So the number at the rightmost corner. So we used a number and suppose this is a decimal and here 4 is the last number. So it has the lowest value. Okay, and so it is called least significant digit. The leftmost digit on the number has the highest weight value. So here we have written, so this is the rightmost digit in this number system. So it has the highest weight, so it is called most significant digit. So this number is called least significant digit and this is called the most significant digit. It has the highest value and this 4 has the lowest value. The digit 7 in the number system, here we can see, is the most significant digit and 4 is the least significant digit. So this has a lesser value and this 7 has more value. The given table shows positional weight of decimal number system. So this is the decimal number given. We are going to learn about the positional weight of this. Position, as the position increases, the weight also increases. So here 3 columns are made, 100, tens and units, weights, real value of each digit and result. So as we already know, in the decimal system we use 10 as the base. So here everywhere 10 is used. Now this is the real value of each digit. Here the number is 724. So 7, this is at the 0 position, this is at the 1 and this is at the second position. So that's why the position is second. So we have written 10 and the position here. Now 2 is at first position. So here 2 is written and here 1 is written. 1 is to the 10 to the power 1 is here. Now with 4 we have written 10 and 0. So 4 is at the 0 position. So we have written here 0. Now the result that comes is we have to multiply 10 2 times with 7. So the answer is this 700. Here we have to multiply 10 only one time. So the answer is written here. And here 4 is to be written because here 0 is the power of 10. So this is the way of calculating the decimal number. Next is binary number system. The word binary comes from bi meaning 2. So the meaning of bi, everywhere we use bi word, the meaning is 2. जहाँ पे भी हम bi use करते हैं 2, उसका meaning होता है 2. For example, bicycle में bi का मतलब होता है 2 पहिए वाला. Binocular में 2 eyes होते हैं जिससे हम देख सकते हैं कुछ भी. So it also has bi means 2 and there are many other words also. The binary number system has the base of 10. So in the decimal number we have base 10. Here in the binary number system we have the base 2. The computer is a machine made up of transistors, switches and other components. All these electronic components are in two mutually exclusive states, either on or off state. So this base means either the computer is in on or off state. So it means here the two binary digits represent these two states. Every instruction given to the computer is converted into zeros and one. So whatever instructions that we give to the computer, that is converted in binary number and then computer understands that. So it is converted in zeros and ones and implemented by the computer. Binary language is therefore known as machine language. So because the machine can only understand the machine language, that's why binary number system is used. So binary number is made up of only zeros and ones. Example of binary number is this. Here we can see 1 and 0 is only used to make a number, and we can see here the base is 2, exponent is 2. Now there is no digit from 2 to 9 in the binary number system. It consists of only 0 and 1. So let's see the description of this binary number. Your names are given, the size and the examples. 1 bit means bit is 1 in size, and single digit either 1 or 0 is written here. Nibble means it is 4 in size and a group of 4 numbers digits are written here. Byte means 8, group of 8 digits are written, and word means 16, group of 16 digits are written in this. So let's learn how to form binary numbers. As a binary number system consists of only 2 digits, that is 0 and 1s. Its base is 2. Each digit or bit in the number system can be 0 or 1. A combination of binary digits may be useful to represent different quantities like this given in the example. The positional value of each digit in binary number is twice the place value or face value of the digits on the right side. The weight of each position is the power of 2. The place value of the digits according to the position and the weight are as follows. So here we can see the position is given and here the weight is given. So here one number is given 3210 and -1 -2. Why? Because this was the number, 2 is used here, and as I have already told you that after decimal 0 is the power, then 1, then 2, then 3. That's why these are written here, and after decimal to the right side -1 and -2 starts. The single binary digit like 0 and 1 is called a bit. For example, this is a 5-bit long. The word bit is made up of words binary digit. So bit is made with the combination of these words, bi from binary and t from digit. Next comes the octal number system. The octal number system consists of 8 digits from 0 to 7. So when we count from 0 to 7, we can see there are total 8 numbers. So it consists of total 8 number system. So octagon has also 8 sides. So it consists of 8 digits from 0 to 7. Hence the digits of octal number system is 8. So the base of octal number system is 8. In this system, the position of 8 digit represents the power of 8. Any digit in this system is always less than 8. So whatever number we write in this octal number system, it should be in between these numbers. It should not be greater than 8. So here we can see there is an example given. So this is considered as invalid because here we can see it is written. So this is not a correct octal number. Next is hexadecimal number system. Hexagon we have learned about. Here now we are going to learn about hexadecimal number and then number system. The hexadecimal number system consists of 16 digits are here in this, from 0 to 9 and A to F. So when we count from here, it is of 10 digits and A to F consists of 6 digits. The letters A to F represent the decimal number from 10 to 15. So after 9, A is written because it is considered as 10. Then B as 11, C as 12, D as 13, E as 14 and F as 15. So it consists of total 16 number like this. The base in this number is 16. Each digit's position in hexadecimal number system represents a power of 16. For example, this number given here is valid hexadecimal number. Why? We can see it is different from this, because here we can see the power is 16 but here the power is 10, which is 764. The number system provides the shortcut method to represent long binary numbers. So when we are talking about hexadecimal number, the number should be from 0 to 9. So here we can see all these numbers written here are between 0 to 9 and 16 is its, you can say, base. This number system provides shortcut method to represent long binary numbers. So this is the shortcut method for representing the long numbers. Next is decimal to binary conversion. How can we convert decimal number to binary numbers? For this we have to either divide the decimal number by 2 and note down the quotient and then the remainder. So we are going to do it. Then divide the quotient obtained again by 2 and note down the result, and then we have to repeat the procedure and list the last question and the remainder, and you will get your binary number. So here is an example. With the example we can learn it easily. So we have to find out the binary number of the given number 80 and the base is 10 here. Base 10 means it is a decimal number. So we are going to convert this into binary number. So as we have learned in our earlier classes, in our smaller classes, how to take out the HCF, we are going to do the same thing here. We have written 80, then we have to divide each number here by 2, and here R means remainder, whatever remainder that we get. So when we divide 80 by 2, we get 40 and 0 remainder is here. Then again we are dividing 40 by 2, 20 comes and remainder is 0. Then again the same procedure is here. Then again 0 comes. But here when we divide this 5 by 2, what happens? 4 is the answer here. So 1 is the remainder, because 2 2s are 4. So 1 remainder is here. Next, at the last one, what we have to do? 1 is remaining and it cannot be divided by 2. So 1 will become our remainder here. So when we write down the binary number here, this is our binary number. We write it in this order. So first we write 1, 0, 1 and then 1, 2, 3, 4. 4 zeros are to be written. So this is the binary number of 80. Here we can see the answer is given. So we have to write the binary number in this way. Again we have to do the same procedure with 72, and when the number cannot be divided, so here 9 cannot be divided by 2 by whole in the whole way, पूरी तरह से divide नहीं हो सकता, तो हम क्या करेंगे, इसकी table पढ़ेंगे और 1 will be written here because 8 comes and 1 is remaining, so it will come here. Again with this we are going to do the same thing, and it is written in this way: 1, 0, 1 and 3 zeros are written. Here is the answer. So this is the way of converting a decimal number into a binary number. Now binary to decimal conversion. How can we convert binary number to decimal number? Here is with the example we are going to do. First start from the rightmost digit. So we have to start from the rightmost digit because it has a lesser value, and then we have to continue to the last digit. So we have to multiply each number by 2 because binary number consists of 2 as a base. So let's divide it. So here we can see with the example we are going to learn. Here one example is given: 4 times 1 is written to the base 2, and we have to convert this in decimal number. So we have written the number. First number is written here, and then because we know that its power is 0, then 1, then 2 and then 3. So 1 to the power 0 when it is divided, multiplied. Next 1 to the power 1, 1 to the power 2 and 1 to the power 3. So this all are written here. Now we are going to multiply them. So this is nothing, so 1 will be written here. So 1 is our answer. Next 2 is multiplied only once. So 2 we have written the multiplication table here. Next 2 we have to multiply 2 times, which means 4. So 1 is multiplied by 4 and 2 is multiplied here 3 times. So when we multiply 2 3 times, we get the answer 8. So here 8 is written, and these are the numbers. So when these number comes, we have to add these number, and the number that we get here, that is the decimal number that we are getting. So here 15 to the base 10 is the answer. Same way we have done this one. Again we have followed the same process, 0, 1, 2, 3 and 4. So we have written all the 1 here. Now this is to be written here and the answer is 1. Now 2 to the power 1, the answer is 2. Next this is multiplied and the answer is 4. Next here 0 is written, that's why here we have written 0, and when we multiply 1 to 0 it becomes 0. Again this number is multiplied to 4. Now we have multiplied 2 4 times. Here in this we have multiplied 2 4 times and the answer is 16. So we are getting this answer. We have to add these numbers written here and then we have got the result 23 to the base 10. So this was how can we convert binary to decimal. Now there is one more example here. We can see decimal is also given in between. We have to convert this binary number to a decimal number. So we have made this table here. We have written the position, phase and the weight. Here we have written the number that was given in our question. Here the number is written, the question is written here, and we have written the positions here of these numbers, and now we have multiplied it with 2. All these are multiplied with 2. So after multiplying all these numbers, we got this result in front of us. We have to multiply these and we have to add them separately. So this is the answer. You have to do like this. Next is operation in binary numbers. Let us learn the basic operations in binary number. First is binary addition. How can we add in binary numbers? So the binary addition is similar to the addition of the decimal number. When the value of the addition exceeds the value 1, say 10 or 11, then 1 is carried over to the left of the current position. The rules for adding two binary digits are given here. So here we can see binary digits are given on the x and the y point. We are going to add them. So when we add 0 plus 0, we get 0 answer. When we add 0 plus 1, we get 1. When we add 1 plus 0, we get 1. And when we add 1 plus 1, we get the answer 10. So here 0 will be written and 1 will be carried. Here is the example. So this is the number. We have added 1 plus 1 and what we get? 10. So here we can see we get the answer 10. So 0 is written and 1 is carried over to here. Now again we are adding this 1 plus 1, we get 10 and then 1 11. So here we are getting 11. So 1 is written here and 1 is carried here. Again we are adding these two, we get 11 and again 1 is written and 1 is carried. Now here is 1 plus 0, which means 1, and 1 plus 1, the carry 1, what it comes? It comes again 10 here. So when we are adding 1 plus 1 here, we get 10 and then okay. So 0 is written here and 1 is carried over to here. Again we are adding 1 plus 1, we get 10, 1 is carried and 1 plus 1, 10. So 10 is written here. So this is the way of adding the binary numbers. So for example, let us add the binary number again. This is given here and we have learned how to add them. Now how to do the subtraction? Same procedure is to be followed. How we do addition? The same process is to be done here. Two x's are given here and 0 minus 0 is 0, 0 minus 1 is 1, 1 minus 0 is 0 and 1 minus 1 is 0. So same procedure we have to follow. From 1000 we have to subtract this number. So here we have to do this correction in our book and we have to put a subtraction sign here. So this is subtract So after subtracting and borrowing the numbers from the next number, we can get this answer. Modern day binary number system was invented by Gottfried Leibniz in 1679. Now quickly come to the recall time. A number system is a collection of numbers used to describe various quantities. The decimal number system consists of 10 digits from 0 to 9. The binary number consists of 0 and 1. Octal number consists of uses the shortened representation of long binary numbers, and hexadecimal number system consists of 16 digits from 0 to 9 and A to F. So let's children come quickly to the book exercise. Here we have to take the correct. Which of the following is called the rightmost digit before the fractional point of the binary number system? So which is the rightmost digit? It is LSD. It has the lowest value. What is the another name of base 2? So another name of base 2 is binary number system. What are the two symbols present in the binary number system? In the binary number system, we can see two symbols are there and they are 0 and 1. Which of the following is equivalent to the decimal number this? So after calculating through that HCF method, we can quickly find out the answer, and the answer is this first one. Next, which of the following is equal to 0 plus 1 in binary digits? So whenever we plus 0 plus 1, we get the answer as 1 here. Write true or false for the given sentences. A number system is a collection of numbers used to describe various quantities. So yes, the answer is true here. The base of decimal digit system is 8. No, this is false. The word binary comes from the BI meaning 2. Yes, true. The octal number system is used as a shorthand representation of long binary numbers. Yes, this is also true. The hexadecimal number system consists of 16 digits. So this answer is also true here. So here only one is false, that one is 2, and the rest are true. So children, let's quickly come to the question and answer. What is an octal number system? It is the shorthand representation of the decimal number system, and it consists of 8 as a base. 8 digits are here from 0 to 7 is used here, and it consists of the base is here 8. Next, how many bits are there in one nibble? So in one nibble there are 4 bits. What do you mean by the base in a number system? So in the number system, the total number of digits that we use in a number system is known as the base. Okay. Next, fourth question is, what is number system? So number system is the collection of numbers that we use to solve any problem, or is to explain the quantity of something, that is called number system. And there are 4 types of number system: the binary number system, decimal number system, and octal number system, and hexadecimal number system. There are 4 types of number system that we have learned in this chapter. What are the rules to convert decimal number into binary number? So for converting decimal number into binary number, we have to divide the number by 2. So whatever number we have to convert in binary number, that is to be divided by 2. Suppose I have to divide 24, I have to convert 24 into binary number. So I have to divide it by 2 till the answer comes 0, and the remainder that we get, that will be the conversion of decimal number into binary number. So children, this was our first chapter. I hope that you understood the number system that we have learned, and also you have learned about the conversion of binary to decimal and decimal to binary. We have also learned about addition and subtraction of binary numbers. So children, I will be waiting for you in the next class with the new chapter. Till then, stay elated and thank you.